Hey guys, so I'm here for a lesson on limits to infinity. So a lot of people have been emailing me saying, Mr. Boris, the limits, they're okay, but could we make them a little spicier? Could we take a limit as we go to infinity? And talk about kind of what does that represent? So what it represents is when you're taking a limit as x goes to infinity. Infinity is not a number. Infinity is just this concept of what happens is you just keep going over to the right and you never stop. So when you take a limit as you go to infinity, you're just saying, well, what happens to the graph as we go all the way over to the right side? So as we just indefinitely go towards the right, is there some limiting value that it approaches, or maybe just goes up towards infinity or down to negative infinity or something like that? Okay, so that's the idea of what we're trying to find. Let's kind of build up our intuition with infinity. So I wanted to just talk for a minute about how to work with infinity. So again, infinity is not a concept, it just means like an unimaginably large number. It's not like a number. But if you take 2 times infinity, of course that's still infinity, right? Twice as big as infinity is still infinity. If you did infinity squared, that's like infinity times infinity, which is infinity still, or infinity to the 5th or 10th or whatever. If you did like -3 or -2 times infinity, that would actually give you negative infinity. Right, you're doing -3 times a million, a billion. Those numbers are just getting infinitely small. Okay, if you did infinity over a number, infinity over 10, that's like saying how many times does 10 goes into infinity? Well, it's still infinite, right? Infinity over any number besides 0 is going to be infinity. What if you do like 1 over infinity? Well, 1 over infinity is basically going to be 0, because you're saying how many times infinity go into 1, or, looking at limit, like what's 1 over a billion, 1 over a trillion, those numbers get closer and closer to 0. And same with any number over infinity, right? If you take like 10 over infinity or 1,000 million over infinity, those are all just going to be 0. Okay. Working with some exponents, if we do like 5 to the infinity, you could think about that as like 5 times 5, like an infinite number of 5s multiplied together. Obviously, that's going to be infinity as well. If you had something like 5 to the negative infinity, well, how do you write a negative exponent, right? Well, x to the negative 2 is 1 over x to the 2. So 5 to the negative infinity is 1 over 5 to the infinity, which is 1 over infinity, or 0. If you took like the square root of infinity, well, what number times itself is infinity? It's still infinity. Some other good ones, like the natural log of infinity. So that's saying e to what power is equal to infinity. Well, e to the infinity is still infinity. So the natural log of infinity is also still infinity. Okay, so that's just kind of some intuition. So some of the limits to infinity are going to be pretty straightforward. The first thing you can kind of do is plug in. And I'm going to put plug in quotes because you can't technically plug in infinity. It's always a limit. But if you take the limit as x goes to infinity of 1 over x squared, that's like 1 over infinity squared, which is 1 over infinity, which is 0. Which makes sense, because if you look at a graph of y equals 1 over x squared, like this graph on the right side, it goes towards 0. It actually approaches what's called a horizontal asymptote at 0. So if you ever see the phrase horizontal asymptote, what a horizontal asymptote is doing is it is a limit as x goes to infinity. These terms are interchangeable. If a problem asks about a horizontal asymptote, it's asking you to take a limit as you go to infinity. Okay, let's look at some other ones then. If we took, so anyway, you could say like this has a horizontal asymptote at y equals 0. It approaches like that dotted line. Never quite gets to it in this case, but it does approach it. Anyway, if we took a limit as x went to infinity of x to the 5th power, well, that would be infinity to the 5th, which of course is infinity. What about negative infinity? Anything different there? Well, what if we took a limit as x goes to negative infinity of x squared? Well, that would be negative infinity squared. Well, a negative is going to be a positive. Infinity squared is still infinity, so that would be a positive infinity. But, if you took a limit as x goes to negative infinity of x cubed, that's basically saying negative infinity to the 3rd power. A negative to the 3rd is still negative, infinity cubed is still infinity. And that actually makes sense if you look at a graph of x cubed. If you go off to negative infinity, so that's like going towards the left side of the graph, you are in fact going down towards negative infinity. Okay, so those are some of the basic limits. We could do some more, right? If you take like a limit as x goes to infinity of like e to the negative x, this is very similar to the negative exponent we did up above. That's like 1 over e to the x in a limit which goes to 1 over infinity, which goes to 0. So that's what happens there. And that graph also has an asymptote of 0. Okay, so that's a general thought. You can kind of plug in the positive and negative infinity and kind of work with that. All right, the next thing I wanted to do was talk about a situation where what if you have a polynomial over a polynomial? So if you have a limit as x goes to infinity, or negative infinity, of a polynomial divided by another polynomial. Okay, and we're going to develop some rules here. So I'm going to kind of try and organize my thoughts in terms of a table. So if you have like what's the situation of poly over polynomial, and then what happens if you take the limit as you go to infinity. Okay, so let's leave some room for that. We're going to fill it out in just a minute. So here's a key trick. And the trick is just look at the highest power terms on top and bottom. So look at the highest power terms on top and bottom. So what if you just take like the limit as x goes to infinity? Let's say, I'm just going to pick a random example here. So let's say 3x cubed plus 5x minus 7 over, I don't know, 5x to the 5th plus 20x minus 2. And basically, you're just going to say, okay, I'm going to pick the highest power terms. That's the x cubed on top, the x to the 5th on bottom. These are what's called the leading terms. The highest power. The coefficient doesn't matter. It's the leading terms. And you basically just look at that limit. So look at that limit. Okay, so you just take the limit as x goes to infinity of 3x cubed over 5x to the 5th. One thing I would recommend is to simplify, so cancel off the x cubes, and this just becomes a limit of 3 over 5x squared, which just goes to 3 over infinity, which of course is 0. Okay, and actually one thing that's also true, this will always happen whenever you have a lower term or a higher power term on the lower part on the bottom. So if you take like a limit as x goes to infinity of, I don't know, like 2x over x squared plus 7, you just look at the top and the bottom, the biggest terms there, and you say, I'll just take a limit as you go to infinity of 2x over x squared. You can cancel the x's. So that's just like a limit x goes to infinity of 2 over x, which is 2 over infinity, which is 0. So that's actually the first thing we're going to add to our table. So if you have the bigger power on the bottom, that limit is going to be 0. Okay. Bigger power on the bottom. What if you had a bigger power on top, right? So let's look, for example, at the big power on top. Okay, you can make your predictions here. So if you have a bigger power on top here, so say the limit x goes to infinity of x to the 5th plus 2 over 3x. Again, let's just look at the leading terms. So this turns into a limit as x goes to infinity of x to the 5th over 3x. I just look at those terms with the biggest power. They're not the ones that go first, it's the ones kind of with the biggest power there. So this becomes, let's see, the x is canceled, so it just becomes a limit as you go to infinity of x to the 4 over 3, which goes to infinity over 3, which is infinity. Infinity to the 4 obviously is infinity. The reason this works, by the way, is because those terms are so much bigger, right? As you get larger and larger numbers, like an x to the 5th is so much bigger than an x, or even an x to the 4th. Like as x gets bigger, that difference gets magnified, right? If you do 1,000 to the 5th compared to 1,000 to the 4, a million to the 5th compared to a million to the 4, the x to the 4 term is just completely insignificant. And that's why this works if you're curious. Okay, let's look at one more example. So for example, if we take the limit here as x goes to negative infinity of 3x cubed plus 1 over negative 2x plus 5x squared. So again, I'm going to look at this and just take a do at my leading terms. Oh my god, that was a train wreck on the top and the bottom. So we're going to say, let's just take the limit as x goes to negative infinity of 3x cubed. My handwriting is like getting worse. divided by 5x squared. We can cancel the x squareds. So this is the limit as we go to negative infinity of 3x over 5. Okay, so as we plug this in, we see this is just 3/5 times negative infinity. So that just becomes negative infinity. Okay, so as long as we have the bigger power on top, we got infinity or negative infinity, and it's going to depend on what the leading terms are, what their signs are, whether you're going to positive or negative infinity. But it's safe to say that if you have the big power on the top, that limit is either going to be plus or minus infinity, and you're going to have to do some analysis of the leading terms to figure that out. Now, of course, all the cool kids in the class are saying, well, bruh, what if we have the same power terms? And we're going to develop a cool shortcut here. So what if you ask for the limit as x goes to infinity of 5x cubed plus 7x squared minus 4 divided by 9x cubed plus 3x? Okay, so you just look at this and you say, all right, I'm going to take the limit as x goes to infinity, again, of just looking at the leading terms, the highest power terms. Because as you go to infinity, those are the only ones that really matter. So I'm going to pick orange here because I'm wearing an orange shirt still. So that's 5x cubed over 9x cubed. Now, again, the cool kids are noticing the x cubed cancel. So that just goes to 5/9. So where did that appear in our original problem? Oh, those are just the coefficients of those terms. And if you do more of these, you're going to see that always happens. Because if you have the same power, those x cubes are always going to happen. So this is just the ratio of the leading coefficients. And this is a great shortcut you can use. Because if you just look at this, like you don't need to do this analysis of leading terms if you recognize the shortcut. Like next semester, we'll just shortcut these all the time. But you'll take some limit of, say, like 3x squared minus 4 divided by 9x squared plus 7x plus 2. And you just look and say, hey, I got a 3, I got a 9. They're both x squareds. Sorry, that 2 is pretty bad with the circle there. So you got 3 over 9, which is just 1/3. Okay. And that's the shortcut you can use. And don't forget what this means. This means that you have a horizontal asymptote at y equals 1/3. So if someone just asks you, for example, like find the horizontal asymptotes of some function, find the horizontal asymptote of, say, y equals 2x minus 3 over 4x plus 6. You look at this, you just say, oh, I just need to take the, wow, I spelled take wrong, which is incredible. I just need to take the limit as x goes to infinity of this. And you see, oh, I just get 2 over 4, which is 1/2. So my horizontal asymptote is y equals 1/2. You might also, in some cases, need to take the limit as x goes to negative infinity. For polynomials, it's not going to matter, and that's more for like an e to the x. But if you see this phrase, horizontal asymptote, again, think of that as saying, oh, I just need to take a limit as you go to infinity, or a limit, or probably a limit as you go to negative infinity. All right, well, let's finish our table then just with this last thing, that if you have the same power on top and bottom, if you have the same power on top and bottom in this polynomial situation, you just look at the ratio of the leading coefficients, and that'll give you this limit as you go to infinity because of this cancellation. Okay, so this leading terms trick I hope is like really powerful. It's going to save you a lot of time, and I hope this video helped. I'll see you guys soon.